Good afternoon, everybody. How's everybody going? Fading fast? Hanging in there? Oh, you still got me to keep the energy up. So, okay. So before I start practical performance testing, let's do a load test. So I was talking with Sean before. He mentioned a domain. So let's be a bit cheeky. Let's kick off. What was it? Immigration dot what? .nz. Okay, cool. We'll just leave that run while we're going. Okay, we'll see if it fares, right? We'll see if it fares. Or should we go back and check? Let's go back and check. Seems to be going all right. It ran through. Oh, okay. It's graded. Did you run it through your cache tool, man? I'm trying. Oh no. Everything's falling apart. Anyway, only joking. So hi, wrong screen. Okay, hi, my name's Schuch. I'm operations lead at PreviousNext, lead architect to Skipper. I love cloud native infrastructure, write a bunch of different languages, and love trail running. If you have any extra time while you're in Wellington, definitely hit up the Wellington skyline. You walk down the skyline, you look to the right, and it's the bay. And it's beautiful, and then you look to the right for that, and you look to the left, depending on which direction you're going, and you look to the left, and it's Lord of the Rings. It's just absolutely phenomenal. But that's not what I'm here to talk about. I'm here to talk about practical performance testing. So let's get a bit of a foundation going to begin with. So what is performance? Before we can test it, before we're talking about the practical side of things, what is performance? Well, it's a few things to me. It's latency and throughput. So to put it really technically, it's how quickly a web server or an infrastructure can process a request. So, and how many of those requests at a given time an infrastructure or an application can push them through. It's also availability and scalability. So it's the other side as well. It's the fact that it's not just the amount of requests that we can bring in, but it's okay, we need to scale up to meet demand to continue to do that as well. We're not just going to bank up and choke and the site's going to go down. But the other one that we don't think of as much with this is also just the perception to the end user. So a site can be beautifully designed, look amazing, have all the features, but if you press a button and get a spinner, and it just keeps spinning and just keeps spinning, then that's a really bad experience, right? And that leads me into performance is quality. Because we put so much energy into the design, the look, the feel, the features, how everything's integrated. But ultimately, the thing that's pushing through that this is quality is when you can click that button and get a quick result, or you can click that button and you're getting a feedback loop. So this is my lovely breakdown. Performance is a full stack, all-encompassing ideology of delivering quality solutions. And on the topic of full stack, that's everything from CDN cacheability to application logic to database tuning to the scaling triggers. It's all the way up and down the stack. So now what is performance testing? Well, it's taking all that and it's measuring latency, throughput, and scalability to meet our expectations. I think the biggest part of this is that measuring to meet expectations. Which leads me into why does performance testing matter? Well, who's been asked this question, like in their careers? Can we scale to meet X? Yeah, like we have a marketing campaign. It's going out, there's a big EDM, which isn't the music, the digital marketing campaign. It's going out. Like, can we meet that demand? We've sent it out to millions and millions and millions of people. Can we meet that demand? Or we shipped a feature. We're shipping a new feature. Can we scale to meet that feature? It's going to be popular. It's It's going to be a big hit. But then the other one, because, you know, we all love AI, but can we scale to meet the demands of AI? Because at the moment, there's been this up until now, there's been this, you're either bots and scrapers or you're real users interacting with your site. Very deterministic. But now, and I know a lot of people have these kinds of slides and we all know it, AI is coming for our websites, they're scraping, they're training, they're interacting with them in every which way. But your site that may have not gotten as much traffic before might actually be a very great target for content. It's understanding your system under load. So it's leaning in and trying to understand the behavior of the system as a whole and your application as a whole. And it's the thought of trying to uncover bottlenecks early. So by understanding the performance characteristics of your applications, you then kind of know where these points are in your applications that are bottlenecks. I'm sure we all have like that one or two kind of things where we go, yeah, we know that's a little bit slow, but that's okay. Now, when we bring this all into practice, so okay, cool, Nick, you threw a whole bunch of theory at me and all this stuff. Let's put it into practice. So what I want to drive home first is performance is an ongoing practice, not a last-minute concern. And that leads me to one of my workspaces. So honestly, this entire talk is just a masquerade for me to be able to show everybody this kind of thing. I've had this in my head for so long, this kind of visualizations. I wanted to write the blog post and I went, I'll do the talk first and then I'll write the blog post. But when going into talking about performance and load and how our system behaves, like I want everybody to think of this mental model of like lanes of traffic. So requests are going in, the application is serving the request, it's going through, it's returning to the end user, happy days. And it's being load balanced across multiple instances of your application. So you've got these lanes. And that can go either which way, right? Like if our application becomes a bit more performant, you know, if we have like a nice fast running application, well, you know, we just halved the threads across our 3 servers. If our application is a bit slow, well then things start to queue up. And maybe in time for things like auto scaling to kick in. And then load balance that across. And then continue to queue up. And why don't we just break it? And just load balance it across. But it's that mental model, right? And if we bring it down, it's not just being able to scale out. It's also the case of, okay, well, you know, maybe we have some performance wins here where like we can be a bit faster in our application. We found the bottleneck. We saved a bunch of time, happy days, and we just have some extra threads. We have extra throughput. We just, you know, made our application faster so the same resources can go the same distance as well. So does anybody have any requests? What do they want? Do they want to see me change a value? No? Yes? I'll talk to the agent after this. So we'll put a bit of jitter in it all, but yeah. And we broke it. Happy days. And I'll probably pause that just in case there's some kind of CPU leak. Anyway, that's the mental model. That's the thing that anytime I'm talking to somebody about performance, they have to sit through that kind of thing to begin with. Whether you're a product owner or a dev or ops or whatever it is, that's the like, let's think about lanes to begin with. So, okay, cool. When should we performance test? Well, before we go live, that's a good idea. That's a great idea, right? Like we want our launches, we want our go lives to be these monumentous, massive occasions where all this hard work that we just pushed through goes to the end and it launches and everybody can go check out our websites. We want to do some performance testing to make sure that our applications can handle that. Identified during discovery, like early on in the project, way earlier on in the project, or just during discovery of the next phase of work. Okay, we have this feature, like we should put some time aside to do performance testing, to performance test that thing. Here's where things get interesting, on a schedule. So it went live and okay, well, how often do we want to performance test? To me, this one actually ends up being more on a sliding scale. I'm not going to prescribe anything to anybody here on when you should. I think everybody can kind of feel when they should be doing performance testing on an application. You might have a very small site with very little, like it's maintained, it's happy days, there's not much of a change. Okay, cool, not much has changed. We only need to do that maybe every year. But then you might have sites where there's lots of things happening all the time, like lots and lots and lots of code changes being merged in, changes to infrastructure, platform all the time. When do you test that? Is it the end of the sprint? We've kind of, with some of our clients, landed on like a 6-monthly rotation where it's like DDoS and performance testing at the same time to go break the thing. So that's up to you. And I think there's like a natural inclination to just automate all this stuff and go, okay, well, we'll chuck it in our CI/CD pipeline and we'll automate it. So every time we deploy, we'll do a performance test and then we'll get those results back. And I think it's a great idea, but at the same time, it's very non-deterministic. Like, I think between CI/CD, there's too many variables. There's too many variables going on at any given time, and I think it will lead to fatigue over time and no performance testing at all, right? Just like anything, it just depends how much you want to invest into it. But to me, CI/CD pipeline testing is something quite niche. We don't do it. We do it with a bit more structure around it. So how do I performance test? And that was actually when I was supposed to show you the slides. So let's get the second demo. So let's get right into it. The first thing you do is you identify pinch points. So we want to find places in our applications or places where things are the slowest. So, and you build a list of test scenarios. So anything from like that search endpoint that you go, okay, like that might be a pinch point because it relies on a back-end service like a Solr or an OpenSearch. It could be a web form submission. I think the term was coined spicy web forms by Sean, like the other spicy forms. Yeah, where they go do things. Yeah, happy days. So let's make that a thing. But yes, spicy forms that go off and do a whole bunch of work. Yeah, it could be a whole bunch of different things. So build a list of test scenarios that you want to execute on. Now, there's a whole slew of tools out there, and they all have amazing names. Like, I mean, Apache JMeter is like the boring one that's been around for ages, but you get these amazing sounding tools now like Gatling and Vegeta, and it's going to go Super Saiyan on your website and break it and blow it up. But for us, we use K6, which is kind of a best of, well, it's done really well for us. It's very simple to write the scenarios in. We've actually done a series of blog posts around it. So getting started, and there's a blog post from Nathan around like load testing confirms your assumptions, or performance testing confirms your assumptions. Great reads on our sites. And then we even have a starter kit around it, which I started, Nathan extended, and I'll show you a little bit around that now. Cool. So this is the basic structure. I just want to give you a bit of an understanding around like what a scenario might look like and give you a bit of inspiration on what scenarios you could write. Like I said, the repository is open source, but we can start with kind of like the basic test. Like I remember like 10, 11 years ago, before a go live, we'd run this test and go, yep, caching works. We just hit the front page 10,000 times a second. Look at all these big numbers. But in reality, that's just the cache doing its job. But this is still handy because if your cache isn't doing its job, it's not a good time. Contact forms, like we mentioned before, you can go to a contact form, fill out the form and submit. You can even do logged in kind of experiences. So you can log in as a user in Drupal, grab the cookie, put it in your test, and then run through the scenario through a series of pages, click where you need to, and run it like a user would. And then page not found. So you can hit the site just on random URLs. I don't know how many times I've seen just 404 pages just being very ill performing. So this is a fantastic test to hit your site with, because a lot of web traffic just guesses paths on your site sometimes. Crawler bots, things like that. So yeah, 404 pages. If there's a big takeaway, it's go check your 404 pages, people. And then search. Like I said, this is all open. It runs through K6, scenarios written in JavaScript. Actual execution engine is all run through Go. Yeah, fantastic tool. And we have a full stack from top to bottom that runs like a Grafana solution. And InfluxDB is the store as well, so you can see pretty graphs, which I'll show you. Cool. Cool. And cool. So that's what the graph looks like from the tester's perspective. So you see everything from the user's perspective. So I know it's a bit hard. Everybody should go home, fire this up and give it a crack on your own sites, preferably not production. But you get the whole breakdown around like number of users, number of requests, throughput. So you get a very unbiased end user, your client kind of set of metrics. And when it's all done, so you've done the tests, you've run your scenarios, and you've got all these pretty graphs from the other side. Well, now it's time to put it into reporting and artifacts, which, you know, I know you weren't yawning over the reporting side of things. But look, it sounds boring, but honestly, how many times like has somebody said, hey, like, you know, how do you like, I can't remember something, you know, like one of those questions, like, can we scale to meet this demand? It's like, oh, we ran the load test, or we ran a whole bunch of testing like 6 months ago. I don't know. I'll have to go pull the graphs out. Oh no, they're not stored there anymore. Okay, I'm not sure. Like, it's actually really important, because it's not just giving yourself and your team and writing it down and analyzing it, which is incredibly important, but it's also then relaying that to everybody else as well, right? It's about building confidence and trust, like up the chain as well. Now, things that you can include are an overview. So somebody who's less technical, right at the top, understands how everything went. Objectives, your approach, so what tools you used, what we're doing this testing because of X, like that's the objective. Our approach is we used PreviousNext K6 solution to test our site. It has, you know, a Docker Compose stack and has K6, happy days. And we decided to use a non-production environment. Highly recommend using a non-production environment that mirrors production. And then our scenarios, why we chose them, ultimately the data that we collected during the exercise, and then action items, because we went through all this to come out the other side and go, okay, here's low-hanging fruit that we can do right now, and here's bigger tasks that we can kind of work on as we go. But Nick, that's a whole bunch of work. Well, I'm glad you said that. Telemetry. I'll just let my users do the testing for me. I mean, we have a lot of, if your site's already live, well then your users are testing it for you, right? They're going to pages, they're doing searches, they're doing queries. So you already have metrics. You already have, response times, origin response codes. You also have things like logging. So you can go, so you could start right now. You could go into your metrics, go into your logs, figure out the slowest paths in the site, see spikes in your P95 and P99 times, and go, ooh, I wonder if that's a trend, a pattern, a path. I wonder what happened there. You can start to build scenarios off that right now, and probably find some pretty low-hanging fruit. My favorite piece of low-hanging fruit is this one, which I almost named the talk about. I was literally just going to call the talk uncacheable, no cacheability, because anytime, I've been fighting this for years and years and years, but there's I was going to say there's a bug in Drupal. It's not a bug in Drupal, but there's just scenarios where when an object doesn't have the cacheability metadata interface attached to it, the fallback in Drupal isn't to panic, which sounds good, but it returns a max age of 0, which means, sorry, we can't cache the page. So if you have one little component that's on a page, the whole thing in dynamic page cache just doesn't get, it doesn't get cached at all. The whole thing is just moot. None of it happens. So it has to recalculate and redo the work every time. Now I'm sounding ranty, but I'm very passionate about it. So, because I see it all the time. But we also built testing and traits around this kind of thing to try and catch it in our testing. But I've still seen it. And yeah, this is 100% a pinch point. Second takeaway, not only 404 pages, but go look through your logs, see if you can find this response or this header. You'll thank me later. Cool. So I found a performance issue. Now what? My recommendation is to do profiling in your local development environment. So start with a local first approach. So we've put a lot of effort into our local profile tooling. So the first one that we did was we shipped an extension called SPX. So it's in our base container images which flow into our local development environments. And SPX is a PHP extension which provides a UI, provides a user a UI, and it can also profile the CLI as well. And you get these beautiful flame graphs. It's all an interface where it has all the paths. You can click on one, probably go grab a coffee because it'll sit there compiling this flame graph for about, depending on your page size, for 30 seconds to a couple of minutes, depending on what your page does or what your endpoint does. But you end up with this very pretty, very beautiful visualization of a breakdown of where all the time's being spent. And this is where we started. The next thing we did is, and this has been a long journey for me, but I've been developing my own tooling around this because to kind of provide a simpler solution, a simple, easy solution that for SPX, it's a fantastic tool, but it literally says do not run in production. But sometimes you can only just debug in production, potentially, or let's just say, oh, that path is really slow right now. Let's quickly fire up a tool so then we can analyze that and just see what it is right now to see how important it is. So we've been investing heavily into telemetry, so low-level telemetry that doesn't require somebody to have to go and add a whole bunch of composer dependencies to their application, but also telemetry that can span multiple languages as well and provide the same experience. So, and that's called Compass. And it looks like this. So it's a CLI first approach. You can see there's a little bit of Node at the top. There's your PHP endpoints at the bottom there. In fact, the first top two, it's a decoupled application. So there's a Node call, then the PHP call to the recipes. It was an umami site. But it's a very, very simple approach that then provides a very simple interface where you can see the memory down the side and the time that was spent. Now, one problem with debugging locally, which we found, was we had an issue on a batch. So somebody came to me and said, hey, this batch that we're running on dev is taking like 50, 60, 70 seconds to execute. What's going on here? It took seconds on my local. Well, I give you the speed of light. So that call was locally profiling it, happy days, a couple of seconds. But because it was tens of thousands of MySQL queries, each one of those has to travel to, like, especially on HA infrastructure, it has to connect to a HA MySQL instance and then come back, and that could be, you know, like a very small amount of time, but then it adds up. It adds up more and more and more. And so with a tool like Pumbaa, you can inject latency into your local development environment to mimic your dev staging production environment as well. So to cover that other scenario. The other side of this is just infrastructure platform level monitoring. So, okay, we've done a bunch of profiling locally, but I guarantee that if you have a slow path, that there's probably something that gets surfaced on the database side. There's something expensive and it's bubbling up. So it's either a very slow PHP kind of logic bug, or 9 times out of 10, it's a slow query of some description. So tools like AWS have their insights, RDS insights. So you get this really nice breakdown of where all the slow queries were over which time and then sort of what category they were. But that'll vary from provider to provider. But tools like this can also help in that debugging. So you've done all the testing, and maybe there's a discussion that has to be had. Like, don't be afraid to get ops involved, or, you know, don't, like, you have to act as a team essentially. Like, we need to, you know, determine, okay, like, I'm saying a lot of application specific things right now, but at the end of the day, guess what? Like, maybe it is an infrastructure problem. Maybe, and you do need both sides of the coin. It has to be very collaborative. And honestly, I'm just going to throw it out there. Sometimes, like, you know, get a completely unbiased, like, opinion. I don't know how many times I've thrown like an FPM, like from the ops side, thrown an FPM config in there and gone, roast me. Like, where's the performance? You know, where's, like, grill me? Like, where's the performance issues? Like, you know, is this, and yeah, and come out the other side with maybe a better, more scalable, more throughput FPM configuration, which then helps on the app side as well. So as I keep saying, like, this is a journey, not a destination. So I just wanted to kind of round this all off with some anti-patterns, some spicy anti-patterns. Number one is my WAF, or my web application firewall, will save me. So yes, but no. Like, what happens when your WAF fails you? If you like this talk, you should, and you didn't see Sean's yesterday, you should definitely go see Sean's yesterday. That is an extremely important part of the puzzle. But then what happens when your legitimate traffic spikes, or what happens when something skips around there too? It has to be a defense in depth approach. And being blind to that and going, our WAF will protect it all, it's that concern, doesn't get you anywhere. Well, it does, your site will be down. So, you know. I'm only responsible for my application. It's the downstream thing that's slow. It's the thing I'm connecting through. That's slow. Sorry, like it's still your responsibility, and whether that's bubbling up the fact that thing's slow, putting a spinner on it, like taking the request, putting it into batch, and then processing that later, and then providing the feedback. There's so much that you can do. Well, there's so much that we all can do to make these kind of experiences better for people. But just going, no, it's that downstream that's slow, I can't do anything is 100% an anti-pattern. It's an ops problem. Make it scale. Add more CPUs, add more RAMs, put more servers in there, scale it up. No. Make it faster. No. No, it's like I said, it's collaborative. It's a shared. Maybe it needs more compute, but let's work together. Let's have that conversation. Let's figure it out. But then, you know, like it'd be very fair to go, you know, it goes the other way too, right? Like the ops person goes, it's the developer's problem. Make it faster. No, work together. Figure it out. Figure it out together. Come to the solution together. And then like I've been saying, it can only be tested in production. Well, if you've seen this talk, now you know you can do it locally. So, cool. Anyway, I keep drumming on about it, but the key takeaways are, this is a journey, not a destination. It's everyone's responsibility. And then you have what you need to go start debugging and testing now. And pizza's a pretty great takeaway as well. So, cool. Somebody asked me how many jokes I was going to have, so there we go. Anyway, thank you everybody. And yeah, what a great conference. We're hiring. And yeah, thank you.